Hello, this is C++ implementation of this graph implementation. We're going to implement this graph using C++. And this graph represents, as I told you in previous video, that it shows the flight in between two cities. For example, between Addis and Cairo, there is a flight with flight time of that is okay 9, and from Cairo to Bahardar there is a flight with flight time of 7, and from Bahardar to Khartoum there is a flight with flight time of 8. Between Khartoum and Addis there is a flight with flight time of 3, and between Addis and Bahardar there is a flight with flight time of 5. How do we represent this one using adjacency list? Okay, first of all we have to create an array of size 4 to represent those 4 cities. To do that, we do have to see this code. Okay. We have to see this code. First of all, what are the data that are stored within these nodes? That is the name of the city and the flight time that it takes from the given city. So to implement this, first what we have done is we have created maximum variable with the size 30. I will tell you why I just declared with maximum equals 30, and just let me remove this, and class node, and we are going to create class node with those variables: node type pointer, next, a string city, and time post. These are the variables that are going to be stored within the given node. Next, public friend class graph. Whatever written after public modifier is accessed within the whole this program. Anywhere within this program, this whatever written after the public modifier can be accessed within the whole this program. Okay, so graph can inherit all the variables of this class node. And what does this node constructor do? Unless we store data to the given node, by default it takes this value. Next is none, city equals none, and time cost is -1 by default. Okay, if we store the given data to the given node, it doesn't take the default value, rather it takes the city coming as a parameter and the flight time, where it is to indicate that the flight time of this city from another city. So city is stored within the given node, and time cost is taken. The time cost takes the value of this weight once we pass it as a parameter to it. Okay. So once we call constructor of this class and pass the parameters, almost all those data are stored within that node. So these are what we are going to implement within this class. Three variables should be considered. Okay, and don't forget this. once we pass these two parameters, the node takes the name of the city from this parameter and store on the node, and the flight time from this into the node. Okay, next next we are going to look at frame class graph. Frame class graph means this graph is the class that is going to be implemented here. Why we have written frame class graph? Because we want the graph class to inherit all the variables within this class. Okay, if so inside the class graph we are going to use a node class because of this. I'm going to use the node class inside the graph class. Node asterisk head max. We are going to create an array of head array with size max. Assume, let's say this is 4 for time being. I do have 4 nodes. Let this be 4. Node type array of head which parts with the size 4. What does this do? It creates an array of size 4, which is this one. An array of size 4 is created like this. An array of size 4. An array of size 4. Okay. Yes. Okay. Okay, an array of size 4 is created. Then what's next? This is created using in this way. Okay, do to out here node type asterisk head of size 4. So this, because of this in the code, because of this this array of size 4 is created. Then what's next? Then what is not type it this. Okay, next we declare variable n and then public. This is the graph constructor. This is the graph constructor, int n, and then n equals whatever comes as a parameter of the constructor graph, n equals m. So this variable determines the size of the node that we are going to deal with, n equals m. Okay, then next, how many nodes do we have currently? 4. Therefore, for int I equals 0, I is less than 4, I plus plus. Here are I equals to all all the index or the head location is assigned null. It is initialized to null like this, like null. Initially no data inside, so null. It is equal to null. Okay. So how do we store those series inside this head node? Inside this head array, how do we store? So this is done by, I will show you the code that does this within this. Okay, let me show you this. Here is the function called read data. I'll send you this code, and it says void graph read data int gtype. So this function stores all those series within this array. How? For the time being, let me comment out all those intercity details and look at. Don't forget to insert. Add this to this location. First, we have to create a node. Always insertion is in the level of node. Always insertion has to take place in the form of node. Therefore, what we do is here int I equals 0 is I plus plus. Here are 0 equals new node. To store at 0's location. Here at 0 equals a new node is created. Then CR enter the city. Then we take from the city. Assume this is Control C. Okay, string name city. C name city. Here our other city equals name city. So we can add this from the keyboard to the zeros. Here are 0 for the first time. Here are 0. Right arrow city equals name city from the keyboard is inserted into that location for the first time. Here at this, and then I increment this to 1. Then here are 1 because new node is created, and then we display this and we take from the keyboard, and then at 1 equals here at 1 right arrow city equals to name city from the keyboard, and then that is Cairo. The same is done for all, that is for Bahardar and Khartoum. For Khartoum. That's good. We have stored all of them. Next, we have to plan a path now. I have to plan from Addis to Cairo. How? To do this, we have to go to the insertion. We have to go to the insertion. We have to go to the insertion. How? We have to go to the insertion. This is undirected insertion. We use undirected insertion. So first, there should be two nodes. Two nodes should be created for each city, and then we have to check whether those cities are found within the head array. If they exist, this is true. Therefore, we do the operation. We are going to plan a path from city 1 to city 2, and index 1 is the location of city 1. So source pointer starts from the first city, and it checks whether its next is none. From city 1 next, is it null? City 1 next, Is it not? Yes, CD1 next is none. Next to CD1 there is nothing. Each series here may have its own list. Currently all of them do not have any list. And at this, its next is null. Therefore, if its next is null, immediately we execute this. If its next is not null, we have to search the last node. If its next is not null, we have to search the last node, and otherwise we execute this. So its next is null, therefore source is at the location of CD1, which is at this currently, which is, let me do this, source is currently here, source is currently here, and then is source next different from null? Is it different from source next different from null? It's not different from null. Next is null, therefore what we do is we don't execute inside because it's next null. Therefore source next equals destination 2. So we make source next equals CD2. This 2 is node of CD2. This 2 is node of CD2. So source next equals this. Source next equals the destination 2 means we are connecting CD1 with CD2. So source next, we are just doing source next source next so source next equals what? CD2. What is CD2 currently? That is Cairo. I want to plan from Addis to Cairo. The source next is null, therefore I can automatically insert CD2 to Addis. Source next is this 2. That is to mean that we are just directly connecting Addis with CD2, which is Cairo. And then what's next? CD2 equals this 2, which is Cairo. Okay. Next, look at now what we have done is this one. The flight is from Addis to Cairo, but not from Cairo to Addis. It's one way. What we have done is this. We have planned a path from Addis to Cairo, but not from Cairo to Addis. So to do from Cairo to Addis, what we have to next do is source pointer should start from Cairo and then search the last of the Cairo. It should start from Cairo, from this, and then it should search the last of the Cairo. So here, so source starts from the index of CD2, and if source next is different from null, we have to search the last, unless otherwise CD2 next equals CD1. This one is almost, this is CD1. Source pointer starts from the location of CD2, and if CD2 next is different from null, we have to search the last node, and otherwise we have to make CD2 next equals CD1. that is city2 next equals city1 means we are just planning path from Cairo to this. So 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 the flight is not only from Addis to Cairo but also Cairo to Addis. Therefore the graph looks like this. To Addis to Addis, Addis to Cairo, and also from Cairo to Addis. This is undirected graph, both side flight. Okay, next. Okay, what's next? Addis to Cairo and Cairo to Addis is done. Next, between Addis to Bahar Dar. Look at from Addis to Bahar Dar. How do we do this? First, to plan a flight path from Addis to Bahar Dar, what we have to do is the source pointer should start from Addis, from this source. From the source pointer should start from Addis, and then it should search the last list of the Addis series. It should start from this, and then its source next different from null. Yes, source next is different from null. There is a city next to source, or there is a city between, next to Addis. So source moves one step forward. So it's on Cairo now. Okay. Is source next different from null? Now source next is null, therefore source is at the last node. Now we can plan between Addis and Bahar Dar. So since source next is null, we can directly make source next equals to Bahar Dar to connect Addis to Bahar Dar. Therefore, immediately we can insert Bahar Dar here. The first step is Bahar Dar. So the first step is the source should start from here and should search the last node, because we want to build a list along this line to just show that those cities have a flight from Addis. Okay, border is connected. How this happens? First, two nodes created for source and destination, and the location of those cities within the array is checked if both of them exist, and then source pointer starts from the city1 and then searches the last element. This searches the last city connected to the city1. So the last node connected to the city1 is Cairo. Then once it gets the last node, source next equals to Bahar Dar means there is a flight from Addis and Bahar Dar. Okay. Next, here there is a flight from Addis to Bahar Dar, but from Bahar Dar to Addis there is no flight. This seems directed graph, but in reality there is a flight from Addis to Bahar Dar and Bahar Dar to Addis. To do this, not only from Addis to Bahar Dar, we have to just plan also from Bahar Dar to Addis. To do this, the source pointer, first we create two cities, that is Bahar Dar and Addis to north, and then we find the index of those two cities, and then if both cities exist within the array this is already done for this part, and then next part is executed here. Source pointer starts from the city 2 and then finds the last node connected to the CD2. Once it gets the last node, and the last node next equals CD1. So first, source starts from the destination 2 and searches the last node connected to Bahardar. So what is the last node connected to Bahardar? Nothing. So we can directly insert another node. So we can what we make is we have to make source next quart add this to make Bahardar next quart. So add this source next quart add this means Bahardar next quart add this. So we are going to insert another node here. That is add this. This implies there is a flight from Bahardar to Addis. At the same time, there is a flight from Addis to Bahardar. Next, Bahardar has a flight from Addis to Bahardar, and Bahardar to Addis. Another flight is found also between Addis and Khartoum. There is a flight. That means Addis has a flight to the Khartoum. So there is some node to be connected here. So Addis and Khartoum. So what do we make first? We have to create two nodes for Addis and Khartoum. Where? Here. We have to create two nodes and store the city on destination 1, city 2 on destination 2, and the time. Then we have to check whether those two cities exist within the array. If they exist means if this is true, if they exist. So what's our first city? That's Addis. Next city is Khartoum. So source also here at index 1. So source starts from the location of the city 1. That is source starts from the Addis city here. Source starts from this. Source starts from here, and okay. Next, source should search the last node to Addis so as to plan a path between Addis and Khartoum. It should search the last node. Is source next? So how does it search? Using the while loop. Source starts from city1, and using this while loop it searches the last node. So is source next different from null? No, it's not different from null. If it's different from null, it moves one step forward. Is source next different from null? It's not different from null, so it moves one step forward. Is source next different from null? No, it's not different from null. It's equal to null. It is source next is null. Therefore, now we can plan a flight from Addis to Khartoum. How? We have to make source next equals city2. Source next equals city2, and city2 is inserted in the form of node, and the node which represents the city2 is dist2. That is source next dist2. Dist2 is the pointer which represents node 2 or city2. So this inserts plans a flight from city1 to city2. So automatically we have a Khartoum here. Khartoum. Source next equals dist2. Okay, next we have to do the other way. Next, source should start from the location of city2. It should start from this to show that there is a flight from Khartoum to Addis and Addis to Khartoum to Addis and from Addis to Khartoum. Source should start from Khartoum, and then it should search the last node. Is source next different from null? No, it's null. We can't have any node next to cartoon. Therefore, once this is null, source starts from the CD2, which is cartoon, and its next is not equals to null. It's not different from null, so we can't search the last node with using this. Immediately we have to make source next equals CD1. So source next equals CD1. CD1 is add this, and add this is represented with dist1 pointer. Dist1 pointer. CD1 is represented with dist1 pointer here. Therefore, dist1 pointer source next equals dist1. So we have planned another flight from cartoon to artist. What's left from artist 3 city? From Cairo to flight. To flight. Okay. Cairo to Addis and Cairo to Baghdad. Cairo to Baghdad. Okay. Now one more is left from Cairo to Baghdad. Now flight is 10. So we have to plan this also. What we have to do is first the source pointer should start source pointer should start from where? From Cairo, and it should search the last node of the Cairo. Source next is not null, so we move one step forward. Source next is now null. Immediately we can insert another node. So source starts from CD1 and then moves one step forward using this. The source starts from the CD1 and using while loop search the last node, and then finally source next equals to CD2. Once it gets to the last node, source next equals to CD2, which is in our case Baghdad. That is Baghdad. Next, the next step is again CD should start source. Previously source started from CD1, which is Cairo. Source started from CD1, which is Cairo previously. Previously started from CD1, and finally after reaching the last node is inserted CD2. Next, source pointer should start from CD2, and CD2, after starting from CD2 location, it should search the last node. Its next is different from null. Yes, go. Its next is different from null. No, false. Therefore, immediately source next equals to CD1, which is in our case Cairo. So this is here Cairo. So there is a flight from Cairo to Baghdad and a Baghdad to Cairo. Cairo to Baghdad and a Baghdad to Cairo. Okay, this is the way we can implement using the source code. We can implement this graph using adjacencies using this technique, and this is undirected graph implementation in C++. You should emphasize this one in detail, and I will send you the whole code. Okay.